Okay, so today we're on day 24. Let's take a look at the example following the class notes. So today's example, we're going to look at this tree data that I have. So I'm going to share the data, and you can follow along on the example, or you can follow along in Minitab. So in this problem, we're looking at people that work in the forestry industry, and they need to be able to estimate the amount of timber in a given area of a forest, right? So we have our data here, which you can see. It should be 31. Yep, we do, and it's 31 here. Okay. And Y is my volume. And my two predictors are diameter and height. So I'm thinking that diameter and height can predict the volume of the tree, the density in the forest. So I'm going to just label this Y, and I'm going to label each of these X. So I'll do X1 and X2. So for diameter, I'm going to use X1. And get over here to this height. I'm going to label this X2. So you know I do this if you've watched previous videos, so then I can just simply refer back to these instead of thinking about it. And what's nice about the multiple linear regression when I do this, it's just I'm going to have more and more columns depending on how many predictors. This way I have the predictors set, X1 and X2. It's just, I feel like it just keeps me a little bit more organized. You don't have to do it. It's just something I do, and I just like to share with you like little tips and tricks of things that I do. So that's one of them. So first we want to build our matrix plot. This is like the multiple scatter plots. It's just a visual of what's going on and what kind of like relationship I have between the volume and the predictors, okay? And it'll actually have the two predictors. I'll have to show you that. So you're going to go up to graph here, and it's the second one down, so it's right below scatter plots. It says matrix plots. Sometimes this is a little slow. I'm going to choose the simple here. Okay, and I'm going to first select my Y variable. So I always do it in the same order. I'm going to select my Y variable first, and then the two X variables. That order doesn't matter, but I will just keep it in the order of X1 and X2. So I'm going to put those in second, and you put them all in at once because I want it to all show up. I'm going to go into my matrix options and just say display the upper right. So matrix display, I'm going to just choose upper right. What it does, if you do a full, you're going to get the double amount of matrix plots or scatter plots. You don't need them. It's just going to flip-flop them or transpose them. You don't really need to do that. So I'm just going to do the upper right. Click OK. I'm going to click OK again. I'm going to show you why I choose the Y first. It's just the way the order comes out, and I just like to do it. And I like you guys do it all the same way as well. Then that way, if I look at your output, it's consistent with mine, and it's consistent with one another. Although the way you read it and the numbers and information you get doesn't matter on the order, just so you know. Sorry, this takes me so long when I'm recording to do the Minitab. I don't know why it doesn't take me this long. It's just the computer's just getting slowed down, I guess. So we'll just give it a minute to pull these up. All right. So this is what I mean when it says upper right. Otherwise, I would have some down here, and it would just be these transposed. It's really, you don't need that many. Okay. So you can see this is why I choose Y first. It's right here, and then I will get the second one I enter in here, and then you can see the third one is down here. Okay, so what I'm looking at with this first one, it looks like it has a stronger relationship, meaning like a straighter line. This is my Y with my X1. So it's Y with X1 right here. The one to the right of it, right here, it's my Y with my X2. Let me just scroll this up a little bit. With my X2 right here. All right, you can see that. And then this bottom one on the right is the X1 with X2. So hopefully that helps you view that. And this is like a really nice way when you have the Y and the X1, X2 in there. So right here, just looking at this visually, I would definitely say that I have a linear relationship between X1, so diameter and volume, for sure. And it's stronger than the other one, meaning it's stronger than height with volume. And then I could have a potential linear relationship between the two X variables. Yeah, so in that case, I might have multi-collinearity. I don't know. I'm going to wait to get my correlation values. I doubt that's very strong. Like, I doubt it. This might be very strong. I doubt that's very strong. That looks pretty weak. But it still might be a little bit of a linear. It looks like it could be a little bit of a positive linear. So here I would definitely say that the strongest relationship is between diameter and volume. Okay, so that's my matrix plots, and it's just nice to get a visual of what's going on. The next thing I'm going to do is get my correlation matrix. So this is just going to give me my R values, and it's just a matrix of them, meaning it's like this, like a whole bunch of them together all at once. Of course, you could get them one by one, like you do single in the simple linear regression, but you don't really need to do that because you have this way. So I'm going to go to the same place I normally go, stat, basic, oops, and where I normally go for my correlation. So correlation here. Okay, so this is the same place I go for my simple linear regression correlation. Here, I am going to select my predictors first. So before with the matrix plots, the scatter plots, I chose my response first. It's the other way around here. I'm going to choose my Y last. So I'm going to put my X variables in first, and then I will choose the Y last. Again, it's just how the output's given when I choose that Y last. I like to look at it this way. I think it's easier. It's not wrong if you do it the other way. If like you enter your Y in first, it's just the way your numbers come out different, but the number values are the same. So the way you would read it is the same. But let me show you what I mean when I say it's like this. You can play around with the options, the results, and the graphs, but you don't need to. We can just click OK and get everything the way it is. Of course, it's going to give me some plots just like it did before. But what I'm interested in is this last box here, correlations. I'm just interested actually in the numbers right here. So I'm looking here, and the reason why I put volume in last is because look at it right here. It's the bottom row right here, because that's what I'm really interested in, right? How X predicts Y. Look at this one. Y with X1, that was the strong visual that we had, and it's a 0.967. That's a very strong relationship between diameter and volume. And then it's not nearly as strong between height and volume, which we could see that in the visual and the scatter plots. We could see it, but it's still moderate and positive. And same thing here with the X1 and X2, the height and the diameter. I would not say we have multicollinearity. That would be if it was 0.9 or negative 0.9 and closer to 1 or negative 1, and it's not. It's just moderate. So we could just leave that alone. If it was really strong, we would just maybe mention it. And that's about it at this point. So we don't really get into much right now with that. Okay. So right here, if I'm going to make a statement, I'm going to say I have a very strong relationship, positive relationship between diameter and volume. All right. So that's how we look at our matrix plot and our correlation matrix. So really nothing new. It's just that I have multiple values to look at, or multiple graphs to look at instead of just one. All right, so let's take a look at building the model. This is what we really need to move forward with doing anything testing-wise and getting any information out. So I'm going to do my regression analysis. It means I'm going to build my model. So stat, regression, regression again. I'm going to fit my regression model. So it's the same place as my simple linear regression. So I'm going to click on that. My response variable is still my Y. My predictors, instead of just having one X, I have two now. So I'm going to enter them both in there. I am not using this last box. Okay, we will only use these first two boxes right now. All right, we're not going to use that last box. Okay, so we may want to get some other information out here. I'm going to wait. Sometimes I think ahead and I know I'm going to need some more stuff. So you can always ask for some stuff to be stored. You could ask for the results to be given to you differently. But right now I'm just going to click OK, just to see what the model looks like. We can always go back in. All right, so here's my model. Here's my equation. This is what I mean when I say regression analysis. This is what I'm looking for is the equation. So right here it is. And I may ask you to interpret some of the coefficients. So if we wanted to interpret something like the diameter here, we would say holding all other predictor variables constant, meaning holding this x2 constant, it's not a variable anymore, I'm saying. Then as my diameter increases for each inch increase, maybe I would say in diameter, because I believe that's what it is, the volume, my y, will increase by 4.708. Okay, so that's how, I think that's cubic feet if I'm looking at this correctly. And that's how I'm going to interpret my coefficients of my predictor variables. And I would do the same thing for height. So holding all others constant for each inch increase in height, my volume will increase by 0.339 cubic feet. The reason why it's increased is because it's positive, right? My coefficient's positive. So same thing as before. So nothing really different there. All right, so now if we want to do a test for significance to see if our model is significant or model is statistically useful, I'm going to use the ANOVA part of the output, the analysis of variance. Here I'm looking at the regression line. So it's the very top line. I'm going to look over and I have an F test statistic of 254.97. My p-value is very small. So yes, my model is statistically useful. It is significant. So if I'm looking at my write-up for this, my write-up would be that beta 1 equals beta 2, and they both equal 0. My HA would be at least when beta is not 0, or at least one is different, you can say. Just saying at least one's not 0, simple enough. I'm going to report my F-test statistic, my degrees of freedom, 2, right here, comma, 28 with my error. So it's 2, comma, 28. So it's the same thing that we've been doing. And then my p-value is very small. So at this point, at the 5% level of significance, my data does show that my model is useful. Okay, so now at this point, this is where I want to kind of look at the follow-up to see, well, what is useful? Which predictor is significant? So this is where I'm going to go to, whoops, I don't want to go down, I want to go up. The coefficients, it's like 2 up. Here it is. So I'm going to look at my coefficients. It's not the constant. I'm looking at diameter or height, right? So I don't have my CI because I didn't ask for my expanded tables, which is fine, but I am going to use my p-values for this. So look at right here, the p-value for diameter is very small. So with a very small p-value, I can say that diameter is a significant predictor variable, okay? Now my height, it's also a small p-value. It's 0.014, which is still less than 0.05. So I would still say with a p-value of 0.014, my height variable is also a significant predictor variable. Okay, so that's the follow-up. So the follow-up here is just showing that both of the predictors are significant. They're both different than 0. That's what that's saying. Okay. So it's just a short little follow-up statement right there. I believe that gets us through 3. B, possibly. And then let's see. Okay, we want to know if our model is practically useful. So we know it's statistically useful with both predictors. So now if we're looking at practically useful, right here I'm looking at my R squared, but I'm going to look at the one to the right here. R squared adjusted. It's adjusted because I have multiple predictors, and it's 94.42. You can see it's very similar to regular R squared. It's just adjusted a little bit because I have an extra predictor. That's all. 94.42, that's very good. So I would use this model to make predictions for my volume. So yes, I think it's a good fit. All right, so that goes through that example. And on your daily assignment today, I'm going to ask you to do the residual analysis. So that's checking my requirements. I asked you in the last one just to do it based on the graphs. I believe I'm asking you to get the graphs. I showed that to you in last class video. So if you have questions on that, you can go back to that video. Towards the end, you will see where I look at that, or in the notes, it explains where to get that. All right. Well, I hope this helped clarify some things for you guys, and I will be available in our class chat. All right. Thank you.